Alright, so we're on day 2 of the unit circle. Today we're going to be starting to get into showing a little bit of a relationship between special right triangles and the unit circle. So let's start with the objectives. You will understand the relationship between special right triangles and the unit circle. You will use your knowledge of special right triangles and the unit circle to determine the points on the unit circle at specific radians. And you will be able to find terminal points on a circle given a real number t. Alright, so let's start with special right triangles and the unit circle. So you might remember in geometry that we had there were right triangles that you could determine the lengths of all the sides if you were given one side, and these were known as special right triangles. Okay, we had a 45, 45, 90, which of course looked like that, and the hypotenuse would be x root 2, and if the hypotenuse was x root 2, that means each of the legs were x. And then we had a 30, 60, 90. The hypotenuse was 2x, the shorter leg would be x, the other one would be x root 3. Not that you need to memorize that. You can, of course, write it down if you like. Not a big deal if you don't. Now, how does this apply to the unit circle? So if you think about the type of angle that 45, 45, 90, and 30, 60, 90 each form, might be a little helpful. So let's go ahead and put a 45, 45, 90 in there. Now this is 45 degrees. And once it hits the circle, if we drop it straight down, that forms a right angle. Okay? And that's at pi over 4, just for the sake of reference. So if we have a radius of 1, and we figure out, because remember, not right now what we're trying to do is we're trying to find where this point is. So this equals what point? Okay, we need an x and a y value. Well, if this is our x, that would be our y. So if this was x root x, and x root 2, how can I get x root 2 equal to 1? What would my values of x be? Well, I'll let you do the math if you want, but take my word for it that it is root 2 over 2. So remember, if this is x root 2, in order to get 1, in order for x to be 1, we'd have to divide by 2. And since we can't have root 2 as a denominator, technically it's that, we can't have root 2 as a denominator, so we multiply the top and the bottom by that to get root 2 over 2. So that's where I got it from. Which means that pi over 4 is at root 2 over 2, root 2 over 2. Okay, and that makes sense, right? So let's move on to, now, you will also have marks at 30 and 60, but I only told you that you needed to know one of these, and that should be for obvious reasons, because we have 30 and 60 as part of it. So there's our 30 degree one, so this is 30. And we do the same thing, take the same approach. We have pi over 6. Oh, let's back up a little bit. And remember our 30, 60, 90, so we've got one that looks like this, and this was 2x, this was x, and this was x root 3. So what would x have to be in order for this to equal 1? Because again, our radius is 1. Just remember, this is a unit circle, so our radius is always going to be 1, which means our hypotenuse is always going to be 1. So in order for that to be 1, x has to equal 1/2. Okay, that would have to be 1/2. And if x is 1/2, 1/2 times root 3 is root 3 over 2. So our x is root 3 over 2, so pi over 6 is at root 3 over 2, 1/2. Now, you might be wondering, maybe you're not, why I said we didn't, we only needed a 30, 60, 90 when we have that third point at 60 degrees. Well, that's because we still have that radius of 1, so our hypotenuse is still 1, except now these values just flip-flop. Okay, so our pi over 3 is going to be at 1/2 root 3 over 2. Because now that's opposite the 60 and the 30 is up here. So you switch it around and you're good. Alright? And obviously you know these points. You know that this one's at 0, 1. You know that this one's at 1, 0. Now hopefully you can figure out the rest of the unit circle based on this. You should be able to determine the radians based on some of the stuff that we did in class. And you definitely should be able to figure out for those radians what the signs are, or what the coordinates are along with the signs, depending on what quadrant it's in. Alright, so these would be the points that you would need in addition to the 4 that you should already know. So if we took a look at, we had all of those. Again, we know that that's 1/2 root 3 over 2. We know that's root 2 over 2, root 2 over 2. We know this one's root 3 over 2, 1/2. Here we're at 1, 0. Here we're at 0, 1. What would the radian measures be around here, and what would the coordinate points be around there? That's a question that I'd like you to answer, and that you'll have to answer at some point. Okay, so those are the points you know. We know the radian measures around there. We know that this is pi. Hopefully you know that this is 3 pi over 2. And then I'd like you guys to fill in the rest of these. So see what you can do, see what you can come up with. And now we'll move on to terminal points. Now, a terminal point is obtained when given a number which we designate as t. So if t is positive, you will figure the terminal point out by going counterclockwise in order the way that we would normally do. So if t is positive, we go that far around. If it's negative, we would go clockwise. Make sense? I know it's kind of backwards, but we had this discussion. So, all right. So for this example, actually 4 examples in one, but find the terminal points of pi. Again, it might help to actually label these. Have a unit circle handy. This is why it helps to have the diagrams. So pi, and it's positive, so I'm going this way around. And when it says find the points, that means actually your answer is going to be a pair of coordinates. Alright, so again, it might be helpful if you wrote down the ones that you know. So root 3 over 2, 1/2. Root 2 over 2. Root 2 over 2. 1/2 root 3 over 2. Okay, now pi, that one's easy. We know that that's at -1, 0. It was positive, so we went counterclockwise around. It ended right on the x-axis at pi, which is at -1, 0. Piece of cake. Alright, so let's take a look at the second one. -5 pi over 6. So now it's negative, so now we're going this way around. Now -5 pi over 6 means we have to go -5 pi over 6 around. Now, as a clue, are we quite going to get to pi? Is this greater than or less than pi? If we don't look at this for a second. Is this greater than or less than pi? This only tells us the direction we're going. That negative sign gets us going this way. Now, since it's less than pi, we know it's got to be somewhere on this side of it. Okay? So what we do then is we go around. So we're looking at right about here. Because if you think about it, remember pi over 6, that's this point right here, right? That's pi over 4, pi over 6, pi over 3. So when we're talking pi over 6, we're talking 30-degree increments. So that's 5 of them. So there's 1, 2, 3, 4. There's your 5th one. Going the other way around. So we look and say, well, what is the terminal point of that? So we still just have to you still do it the exact same way. You still go around and say, well, if I was to look at that, I would say that my terminal point is, because the terminal points don't switch just because you went the other direction. We're still looking for a coordinate point. So this one, we're in quadrant 3, which means that they are both going to be negative. Okay? And this is 30 degrees, right? 30 degrees from the x-axis. So is this one. So we're going to just say that's -3 root 2, negative 1/2, because if we were to draw a line, basically when you connect them like that with a straight line through the center or through the point of origin, they're going to have the same measure. The signs are going to be the only thing that's different. So they're going to be at the same points, just different signs. So it's basically that easy. Now 7 pi over 4. Again, now that's going positive, so we're going to go pi over 4. We're talking basically, half of a quadrant right there. So we go around, even though that went the wrong way. 7 pi over 4 takes us all the way around to right here. Alright, so if this is pi over 4, this is 3 pi over 4, this is 5 pi over 4, 7 pi over 4, we're good. Pi over 4, we're at negative, or not negative, we're at root 2 over 2. Root 2 over 2. Now let's just go ahead and figure out the signs. We're in the fourth quadrant, so our x is positive, but our y's are negative. Okay, again, because we're talking about our 45-degree angle here, which is these coordinates. Okay. And last but not least, now this one could be a little bit tricky. We have negative 29 pi over 6. So negative tells us that we're going all the way around. We're going this way on the circle. Okay, now 29 pi over 6, you have to remember that a full circle is 2 pi. Alright, so you can count each one of these revolutions as 1 pi. So if we did that, how many times? Remember, 1 pi over here is 6. So what I would recommend doing, and this is just me, but I would recommend saying, okay, well, I know that if I can subtract 6 every time I go around 180 degrees. So basically, if I had, the negative tells me I'm going this way. Okay, so if I went 1, so 29 minus 6, that's 23. 23 minus 6, that's 17. 17 minus 6 is 11. 11 minus 6, that's 5. Okay, so basically I get down to where I can't subtract 6 anymore. I've got 5 pi minus 6. And I just say, okay, well, that's over here, which again, as we saw, this is basically, these two are the same thing. So this is also going to be at negative root 3 over 2, negative 1/2. If it's a little confusing, there is a section in your book that you can read up on. This is 5.1, so you can read up on this, and it might be helpful to see it in your book rather than just kind of hear about it and see it on here. But that's just how I do it. If you can find a better way that helps you understand it, then by all means do so. And that's it. Sorry for the little bit of a longer video, but you guys have a great night.